Hello, Chemistry 222. Another chance for you to let your inner child out and earn some extra credit bonus points. So since we just did states of matter, which is what your midterm is on this week, I thought we should be doing some more playful time with geometry. And also because I got a reminder on my phone today, I was supposed to be doing this with a bunch of kids. So what's a mathematician's favorite vegetable? Well, what do you think? Cabbage, celery? This could be part of your extra credit. You could take a picture, make your food into something like really cool geometry, take an awesome picture. What these all have in common is actually the question. And it is, they may know, if we keep going and going, no matter how far we keep going, it just keeps repeating forever and ever. It is a fractal. Fractals are everywhere. They're everywhere. So I don't remember what all these pictures are of. But they're bright, they're weird, they're beautiful, they're repeating geometric figures with very special properties. So this is the old, easy geometry. It's circles, squares, triangles, and it's from around 300 BC by this guy, as they may know. What his name is? Is that Pythagoras? No, although we did talk about him. Archimedes, Fibonacci, Newton. Oh, it's E. It's Euclid. And yeah, all right. Fractal geometry is much younger. It's a newer field. And it has to do with repeating never-ending patterns, that the pattern just keeps showing up. And this is the example of where fractals, the idea came from. And this is why they're awesome. So the thought process that the gentleman went through was, if you measured a coastline, and I said you have a mile-long ruler, and then your lab partner has a foot-long ruler. So who gets the longer measurement? Well, of course, your lab partner can get into the nooks and crannies with the foot-long ruler. So your lab partner gets the greater length. But what if a gnome came along? Well, actually not a gnome. Gnome would have an even smaller ruler. But yeah, so somebody comes along with an inch-long ruler, they would get the teeniest, tiniest crannies, nooks and crannies. And you could measure it with shorter and shorter and shorter rulers and get down to the gnome ruler, and eventually it would get longer and longer and longer. The coastline would just keep getting longer until it was infinitely long. That's what a fractal is. And they're everywhere. They're pretty much what nature is. So this is the gentleman who came up with the idea. The bottomless wonders spring from simple rules which are repeated without end. So the coastline question was what he thought of and where fractals began in the 1960s. He was like, how could you measure the coastline of Britain? In 1975, he came up with the word fractal because he thought these figures would look fractured or broken up. And then computers became more available, and he could see the picture of what he'd been thinking about in his mind. Mother Nature, she's all about fractals. She doesn't fool around with squares and triangles and the old clunky stuff. She uses these complicated, these are all fractals, complex patterns repeating, simple process over and over. The clouds have been amazing this weekend. And then we get the Fibonacci spiral, right? So there he is. And I'm not going to even try to say his name, but Leonardo, yeah, a whole long, those were all the different things he was named. And he was considered to be the most talented Western mathematician of the Middle Ages. And I guess that's what he wrote about. So he wrote the Big Book of Calculation, which popularized Hindu-Arabic numeral system for you and I, where why we have numbers, and decimal. He also introduced Europe to the famous number sequence that you all know. I'm assuming you all know it, even though nobody commented that one of your worksheets or study sets was numbered with his spiral. So the Nautilus, which if you go to the beach, is one of the most famous examples of a fractal in nature. It's created by drawing circular arcs, connecting the opposite corners of the squares following the Fibonacci sequence. So for those of you who don't know the sequence, you start with the number 1, and then you add up the 2 ones, and then you add up the 1 and the 2, and then the 2 and the 3, then the 3 and the 5, then the 5 and the 8, then the 8 and the 13, then 13 and 21, and so on and so on. And that's, I believe, the area of his little geometry. So there you go. That's his wonderful. So the ratio of the length of the short side of the long side is 0.618. The Greek architects thought it is most visually pleasing rectangle. Its dimensions are used in all of their building constructs. Classical artists believed it produced the most visually pleasing figures. And Mother Nature, oh, it is what your face is. And so it's how our ear, our forehead, right? Our chin and mouth. And isn't that amazing? I had no idea. And there they are. There's some examples out there in nature. The thing that was really crazy is 4 years ago when I first did this, and I didn't really know about these. It like opened up this whole thing, and then I went for a walk pondering it because I was just like so excited. And on the sidewalk, halfway through my walk in my neighborhood, these were drawn on the sidewalk by some child. And I was just with sidewalk chalk, and it was just so awesome. Yeah, the fiddleheads, the ferns. You never look at nature again the same way. The sunflower. Isn't that awesome? All right. It's all around us. It's everywhere. In a pine cone. Just a pine cone. It keeps repeating in this sequence. All right. In a pineapple. In a daisy. Fractals. Looking at a tree. Yeah. There we go. There's the fiddlehead. These are all over right now. I don't know what that is, but it's gorgeous. And that, of course, is the dandelion. You can blow it and make a wish because you're blowing all these beautiful fractals of fairy dust, because that is what fairy dust is. But it keeps repeating. So we have the whole. So the whole picture keeps showing up, and each smaller and smaller picture has the whole picture in it. So it just keeps repeating itself. It makes you reconsider your thoughts of the universe. And then geology, of course, is fractals. So mountain ranges and coastlines and deserts and rivers and fjords. And that is a bismuth crystal. That's a fractal. And if you go in the caves, those are fractals also. And yeah, that's a mold spore apparently. That is a chameleon's tail. Keeps repeating itself. And so if you go down and you look at one of those pieces, it's going to be the same as the overall picture. And as you keep looking down into each of these, I forget what this is, but it's gorgeous, isn't it? Oh, that's what it is. There you go. And that is, I believe, looking under a microscope at a piece of some kind of wood. And if you keep getting closer and closer and get a better microscope, it just keeps being the same thing. All right, or peacock feathers. So you can let your feathers out. So if you want, I didn't put this in the actual lab, but if you're a pancake artist and you would like to make fractal pancakes, you just gotta take a picture of them. You gotta be in the picture because, you know, otherwise you could just download this picture like I did. And come up with your own fractal or geometric shape. All right, so which ones are you going to be making? Well, this is it. This is, so each, this is the overall, and then we can take down, and you can see there's 4 of them there, and then we can just look at this white one, and oh, there's the 4 repeating tetrahedrons, right? 4s, and then oh, we just go into this one, and then we go into this little one, and so it just keeps repeating and repeating and repeating itself. And so this is one of your challenges, is to see how big a fractal tetrahedron you can make. So this is called the Sierpinski triangle. It's an equilateral triangle, and it's our most basic example. So there we go. And it keeps getting smaller and smaller and smaller and just keeps repeating. All right. And let's first go through some reviews of some stuff. What is a tetrahedron? Well, there we go. This is a pyramid. So it's a square-based pyramid. That's a cube, of course. And so tetrahedron, we've seen this term, and it is one of your challenges if you decide you want to try that. If you try all of them, because we all need to let our inner child out, and there's more reasons you should. So 3-dimensional shapes made of 4 equilateral triangles. That's why it's called tetra. So there's a triangle on the bottom, and then these 3 up above it. And it's considered one of the 5 perfect polyhedrons. The cube is also, but these are there. They're in the lab, that, or the extra credit that I posted. So the tetrahedron, the octahedron. So this is the square-based pyramid. So the Great Pyramids in Egypt are actually an octahedron. Most of us only see the pyramid part and don't realize it was actually made as an octahedron. So something you can look into. And then here's the dodecahedron. This is the hardest one students have had to make. Because of what you have to make it with. All right, so Plato, you've all heard of Plato. He came up with this idea that there are 5 perfect shapes. And any way that you turn it, it looks the same, is the idea. Actually, the cube is also a difficult one to make because it's not practical. And the thing that's fascinating is the 5 perfect polyhedrons, or Platonic solids, are considered the sacred geometry, and they've been used, they're still used by many people. Many people wear them as necklaces or crowns, and they repeat on the molecular and cellular level of life. And so they each have an element associated with them. So earth, or solid, is the cube. Which is interesting because when we did solids, they were cubes. The tetrahedron is fire. And so think about it, methane and all the carbon-based things that we burn and heat, combustion is tetrahedron. The dodecahedron is the universe itself. Water is an icosahedron, and it probably has to do with, look at all those 100, I don't know if they're 104-degree angles. An octahedron represents air, or the gas state. All right, and there we have it. That's our tetrahedron, the carbon in the middle. And I don't know if you remember me saying, I don't remember this class, I actually have a video of a guy I absolutely love. I listen to his meditation every day, first thing in the morning and before I go to sleep, because it's beautiful. But I found him doing the meditation, and he's actually sitting inside of a tetrahedron. So he built himself a giant tetrahedron. So the tetrahedron, they each have a color because they're each associated with a chakra, which kind of doesn't make sense. But apparently tetrahedron is orange, its element is fire, and enhances the 2nd chakra, even though fire is usually associated with the 3rd chakra. So I plagiarized this off of a website, so some of their stuff might not be correlating perfectly with the chakras. Anyway, it amplifies the energy, as well as memorizes and diffuses your intentions. So carbon helps to amplify our intentions, and we are carbon-based beings, right? It channels the sky's energy towards the earth. And yeah, we should be humble because we are humans, which is where the word comes from. All right. It's one of the 12 aspects of dignity. There is humble warrior. If you see the tetrahedron in there, many people tried to do this in the yoga studios, but maybe you're into Rice Krispies more than pancakes. You can make fractal Rice Krispies, or you can make Rice Krispie treats of the the 5 platonic sacred geometries. That is a star tetrahedron. It is a double tetrahedron, and it is considered, yeah, this is the one a lot of people wear them. It harmonizes the male and the female, balances the two sides of the brain, and there you go. You can buy a necklace, and it helps you to always make the right choice. Imagine having that when you're taking an exam. And it is actually, you guys know, this is Leonardo da Vinci's perfect human drawing, and it is actually in a double tetra or a star tetrahedron. All right, and this one, well, that was the dodecahedron, which is considered the most powerful and versatile of them. And it facilitates communication, and it decontaminates a room. Now, I did not make this slideshow today. I made it 4 years ago. Fascinating. But can make it for decontamination. What if we all wore these around and just decontaminated everywhere? All right. It amplifies our intention and enhances all the chakras. As opposed to, that's supposed to say Megatron's cube. Oh, it's called the Metatron's cube, and it is as Megatron, and that was his cube. Does not decontaminate areas the same way. But when I got to see this movie when we were in, I saw it, Joey was 10 when it came out, and I probably saw it 5 or 10 times, so I had it pretty much memorized, and absolutely loved the movie. And then when we were in China 10 years ago, we happened to be on TV, and it was in Chinese, and it was so awesome because all the robots spoke in Chinese, and I knew what all the words were, and it was so funny. It's a very funny movie, especially in their language. All right, so this geometric shape has 10 pentagons and 20 hexagons. It's a fused ring truncated icosahedron. So this is another bonus point you can try for. And it is, so the icosahedron has 20 triangular faces. This is a really hard one. People have a lot of trouble making that one. Leonardo da Vinci described this structure that's here. I haven't said what it is yet, but some of you might know. And it is why Mary Poppins always had eternally youthful skin, because she was covered in it. It won a Nobel Prize in 1996. And it is in Star Trek when they went through the wormhole in Deep Space Nine. It has names of Buckminster Fullerene, Buckyball Fullerenes, or simply Carbon-60. And so this is Buckyball, and it was named for this guy. He actually went through an extremely depressed point in his life and almost committed suicide. And on the side of Lake Michigan, outside of Chicago, suddenly had an inspiration. And he created these domes out of this shape. And so when they discovered Carbon-60 in chimney soot, and realized, so these are carbon, it's 60 carbon atoms, and there's instructions in the extra credit I posted of how to build it. It's really fun. It's hard to build because whatever you build it with is going to be too dense as opposed to just a carbon atom. But these carbon atoms would all be a covalent bond. So this is like one of our macromolecules. And so it is considered another form of carbon. So this is a buckyball. It does resemble a soccer ball, interestingly. And so it's a tiny cage and looks like a soccer ball. But it's more like a round raspberry is what they say. It was first created by lasers at Rice University in 1985, and it is nanometer in diameter. And so it can trap an atom inside. And yes, this is where we're going to get to, and inspired all the other carbon shapes that you all have heard of, perhaps, and including these, the nanotubes. So they can trap an atom in there. It's one of the things like in chemotherapy, that it could deliver the chemotherapeutic agent to the cell. And of course, nanotubes is a whole technology revolution that has changed stuff. And there you go. That's a picture of it, I believe, with an electron microscope. This is the original where they isolated it. And yeah, it inhibits an enzyme in HIV. It's a superconductor. It's a regular pressure hydrogen storage. And it's just awesome looking. All right, other allotropes of carbon. Let's see if you know. These are all those macromolecules because it's all covalent bonds. So A is a diamond. Each carbon has 4 covalent bonds, and everything's covalent bonds. There's no intermolecular forces in here. So these guys don't come apart. B is graphite, which is also a macromolecule, but because it's in sheets, it actually conducts electricity weakly, not like each week, 7 days, but has a very mild conductivity, which is another Nobel Prize, which I think is the next slide. I don't know what that is, but that's carbon-60, our buckyball. There's another one. Technically, these are not molecules, but are called macromolecules. So G is just the bad hair day, and H is the nanotube, or bucky tube. So if one of them inspires you and you want to do your paper on them, sure, why not? All right. And this won a Nobel Prize. So if you take a pencil and you scribble on a piece of paper, like the side of the pencil, and make a smear, then you take a piece of tape and lift it up, you get a 1 atom thin layer of graphene. And it's supposedly, they're already making phones and stuff and batteries that are this thin and this light and 100 times stronger than steel. Our world's going to be very different and really amazing. And there's another picture of that. So graphene would be a cool molecule. And yeah, look how light it is. That's a flower. This is a real picture. It's not Photoshopped like every other picture out there online is. All right. Yeah, there's another picture of it. All right. So what are you going to try and build? Well, what are your building blocks? Spaghetti, but it's going to be uncooked spaghetti. If you cook the spaghetti, it's definitely not going to work. And marshmallows, mini marshmallows. So you got to go buy a bag of mini marshmallows and a bag of spaghetti. So it'll cost you about $2. And I will give you a hint. You want to open the bag of marshmallows and leave it open for like 2 or 3 days before you do this. Or if you're in a hurry, put it in the oven at the lowest temperature, like 100 to 200, not higher than that, for like an hour. Because when they're really soft, it's hard to get things to stick. You're supposed to try and do it with the spaghetti, but most people end up giving up and switch to toothpicks. So if you decide you can't do it with the spaghetti and you want to switch to toothpicks, they also cost like actually even less. I think they're like 39 cents for a box of toothpicks. And the lab has the pictures of and instructions. I'm not really sure what that is, but maybe you'll come up with your own beautiful new shape also. All right. And yep, that's me. That's Joey. This is what I did 4 years ago. Is another challenge is to make a fractal, and our fractal you got to take your picture fast. You can see I got my fractal on my head. And some people's fractals didn't work as well. That's a smaller one, and mine was the next level, and this was the next level, and the big one's back behind that wall, and the picture that has all the kids in it, so I can't show that. I also can't find it, but the instructions are in what I posted under extra credit. And so you use 4 marshmallows and 6 toothpicks for each tetrahedron, and then you keep repeating, except you don't, they're gonna start overlapping, so that's just a close-up. There you go. And then we can decontaminate the lab, which again, ironically, this is how I ended the slideshow 4 years ago, was let's go decontaminate the labs. So maybe if we're allowed in the labs this summer, maybe the first lab we'll do is build these. And you guys can all come into lab the first day and we'll decontaminate. All right. Let me see. Oh, that's it. So have fun, do it, let your inner child out, and earn some extra credit points, and have a beautiful day.